Hello everyone, welcome back to my YouTube channel, and this is episode 79, and today we're going to continue about our science. If the barometric pressure over the central region remain steady, that part of the country will probably continue to have fair weather. However, if the barometric pressure drops steadily, the weather will become unsettled and possibly stormy. The region with low pressure systems are experiencing areas of precipitation. If the barometric pressure rises steadily, the atmosphere in these regions will probably become clearer and drier. Wind systems. Wind is simply moving air. Several factors determine in what direction and how fast the air will move. These factors include temperatures, air pressure, earth rotations, and topography. The first two factors, temperature and air pressure, work together to produce a basic cycle of air movements. Differing surface temperature create different areas of air temperatures. Air temperatures surrounding air from high pressure areas that then flows into to fill the low pressure area, producing surface air movement or wind. The greater the pressure difference, the stronger the wind. The warm air in the upper atmosphere flows to a place of lower pressure and cools. As the air cools, it eventually returns to Earth's surface and the cycle continues. How do the other two factors, topography and the Earth rotation polar, affect wind? The answer to that question depends on the wind system. Earth has two basic wind systems that affect on the weather. One system is the global wind system and the other is the local wind system. How are the two systems different? The global wind system includes three wind cycles or cells in the northern and the southern hemisphere. The first of these, the heavenly cells, involving the warm air at the equator. Warm equatorial air rises and moves away from the equator toward the cooler air at the poles. As the air cools, it falls back to Earth about 30 latitude north and south of the equator and flows back toward the equator. The polar cells from the cells form when the cold air polar air warms as it flows above Earth's surface toward the equators and rises at about 60 latitude. As this warm air rises, it flows at higher latitudes back toward the poles. The air cools and falls back to Earth at the poles. Then the cycle at each pole begins anew. Between 30° and 60 latitude in each hemisphere is the third cycle of air that called the Ferris cell. The movement of air in the Ferris cell is opposite the flowing in Hadley cells and the polar cells. These three wind cells make up the global wind system. If global wind system move from the equator toward the poles or from the poles to the equator, I would think the wind will always blow either directly north or directly south. That would happen only if Earth was not rotating on its axis. Earth rotation causes winds in the northern hemisphere to move to the right of the direction they are blowing, and it causes the wind in the southern hemisphere, and it causes to move on the left they are blowing. The effect of the Earth's rotation on the global air circulation is called the Coriolis effect. After they finished washing and waxing the car, Ace went to get the basketball and his dad went over to the park. Yes, and this is what I learned in my science. At different times of year, trade winds are located farther north or south at other times. Many years ago, trade ships sailed during the times of year when the crew could depend upon the trade winds. And in the Ferris cells, the Coriolis effect causes the surface wind flowing toward the poles to return eastward. Yes, and this is about my bye-bye.